Alright, so 3.7 is on properties of quadratics. So some different things we need to know about quadratics. The first thing that we're going to talk about is not just a property of quadratics, so we're going to look at some other equations in here as well. And that is your domain and your range. Have you guys heard those words before? Domain and range. So domain is your possible x values of a function. So it's any x that you can plug in and it works out for your equation. The range is the possible y values of a function. So let's look. We're going to look at the first couple together here. I want you guys to graph these along with me on your calculator. So go to y equals, type in this first equation here, x squared minus 5x plus 7. If yours, alright, so if you've got, we've been doing some weird stuff in pre-cal. If yours has R's and weird stuff, hit mode. Yeah, if you've got R's or thetas or weird things showing up, I think you did to the third power instead of to the second. Alright, if you've got weird stuff showing up, hit mode. Go down here to the fourth line. It should say function. Yours is probably on POL instead of function. So choose that very first one right there if you've got weird stuff showing up on your graph. Also, when you graph it, if your window is terribly different than this, if you hit zoom and number 6, it'll take you back to this window here. Actually, I think I had my own zoom square. Okay. Has everybody got a picture now? Alright, I'm going to put this over here a second. Alright, so, when you were talking about domain, alright, you were talking about what possible x values can you have. So, remember also that at the ends of this graph, you've got arrows, right? So this graph keeps on going forever in this direction and forever in this direction as well. Okay? So, when we're talking about x values, we're looking at this x-axis and we're trying to see if the function has a value at any of those points. So like, for example, right here at 1, my function has a value of like 4 or something like that, right? So it does have a value. So everywhere that I see right here, all of these, you can almost think of this as a vertical line. I'm going to make that a different color so you can see it. Okay, so you can think of this like a vertical line. Like for every x value that you have, it's touching somewhere, right? Now, right here, it quits touching. But if we continue this line on up, and continue the graph on out, it's going to keep going forever in that direction. So it still has an x value all the way out here. Same thing in this case, because we've got arrows on the end of this, it continues on forever here. Alright, so for our domain for this problem, we're going to say, we can say our domain a couple different ways. Our domain, the one I think you'll see most often is x equals, you might see all real numbers, or it's more likely that you'll see this x equals and this r that has 2 bars. That means all real numbers. Mathematicians are lazy and don't like words, so they try to avoid them as much as possible, so they make symbols that mean words. So I like that. That's one of my more favorite math symbols. Need some earrings, like that. So that's one way that you'll see this written. I also want to introduce you guys to what we call interval notation. I don't think we necessarily have to do it in Math 2, but because you guys are honors and you guys are headed to pre-cal one day where you will have to do this, I'm going to go ahead and show you right now because I think it's easier anyway. Interval notation, for what you'll do for that is, for interval notation, we use a parentheses if we want to use like a less than sign, and a bracket if we want to use a greater than sign. For this one, it's not going to really help you a whole lot. But so we would go from negative infinity to positive infinity. That means all the numbers, right? So negative infinity to positive infinity, that is all real numbers. You'll see on the range for this one how it's a little bit different. Let me give myself a little more room here. Can't draw an infinity. Turn your paper sideways and draw an 8. Okay, so if I go back to this picture, now I want to think of y values. So y values, I'm no longer thinking of this vertical line. Am I ever going to get a y value of -5 for this? Because -5 is way down here, right? So I never get a -5. So if I were to think of this as a horizontal line, alright, so if I think of this as a horizontal line, then when I look at this, like right here, there's actually two y values that have the same value right here, right? So that, it's a little, if you remember vertical line tests when you were testing for functions, it's a little like that, but it's different. So don't think of it quite the same. But right here, I've got y values. If I keep going up, am I going to have y values? Yeah, because I've got arrows on the ends there, right? Those keep on going. So going up, but whenever I move this line down, what's the lowest y value I'm going to have? Maybe 1. I think it might look a little bit lower than 1. I don't think it touches 0 though, because a little bit of space. So we could guess, but I'd rather not guess. Okay. So let's think. There's two ways I'm going to show you how to find that point. This might be on calculator active. It might be on calculator inactive. So if it is on calculator inactive, that lowest point is my vertex, correct? So my vertex, I've got two ways I can find the vertex. It's either between my x-intercepts, or it's negative b over 2a. Which one do I have to use here? Negative b over 2a, because I don't have x-intercepts, right? So, so if I do x equals -5 over 2 times 1, I get 5/2, or 2.5, right? And what this one in particular, because it turns out kind of ugly, is probably not going to be on the calculator inactive, but just in case it was. But that's my x value. And I'm talking about range, so I'm not worried about x values. I want to know the y value. So how do I find the y value of that vertex? Plug it in. So I plug in 2.5. So I'll have 2.5 squared minus 5 times 2.5 plus 7. And we are going to just grab our calculator for that. 2.5 squared minus 5 times 2.5 plus 7. And we get 0.75. Okay, Philip guessed it right. Okay, so the lowest possible y value we can have is 0.75. Okay, so we would say that our range, we can write it a couple ways. We could do it with inequality notation. So we would say y is greater than or equal to. I'm going to use or equal to because it can equal 0.75. It just can't go below it. 0.75. Right? Because we've got 0.75 as our lowest, and we can have any number above 0.75. Okay? If we want to use interval notation, which I said I like really even better. Interval notation, if you have a parentheses, that's like a greater than or a less than. If you use a bracket like that, that's like greater than or equal to or less than or equal to. It means the point's included, right? So the lowest number I could have is 0.75. Do I want to include 0.75? I do want to include, I use the or equal to right here. It can equal 0.75, right? So I will use a bracket for my 0.75. And then that just goes up and up and up and up and up forever. So what number am I going to? Infinity. And always use a parentheses with infinity because you can't ever actually get to infinity. You can't include infinity because you can't actually get there. So that is your interval notation. Okay, let me show you one other way we could have done this on our calculator. Let's go back to our graph and follow along with me and try these steps here. You should have the point. We can find a minimum point on our calculator. And if you ever need to find something like that from your calculator, you're going to go to the calc menu. So you'll do second trace. That gets you to the calc menu on the graph. So hit graph first if your graph's not up there anymore. And then you're going to press second and trace. Gets you to the calc menu. And then from there, it should be pretty easy to figure out which one you want. Which one do we want here? We want the minimum point. Sometimes it's maximum if it's upside down. So minimum. And then it's going to say left bound and have a question mark. So you just have to put your little spider here somewhere on the left side of the minimum point. Which here is fine. You can go a little closer if you want, further away, it doesn't matter. Somewhere on the left side of that minimum point. You'll hit enter to tell it, yes, I'm on the left side. Then you're going to go to the right side. So you got to go all the way past the minimum point over to the other side of the hill. And hit enter. And then sometimes it gives you a little better estimate if you guess, but if you go back towards the middle to guess, but technically you don't have to do that. You could just hit enter. Okay. Now notice, I did not get 2.5. I got 2.4999986. Did some of you guys get 2.5? Some of you got 2.50000 something. Alright, the reason that the calculator does this is because it is actually not finding the exact number like we did whenever we plugged in the numbers. It is doing an approximation process. So, but both of those are so extremely close to 2.5, we're just going to round it to 2.5. So if you get a number like this with a bunch of 9s or a bunch of zeros and then 1 or 2, then just round it to whatever it's closest to because the calculator is approximating. Okay, so we get we get 2.5 here, but the y is what we really care about. That's the 0.75. Okay. Okay, so let's look at the next one. Let's graph y equals negative 2x squared minus 3x minus 1. Okay, so domain, x values, is there any x value I cannot have? If I put a, where'd my vertical line go? Oh, it won't work over that. If I took a vertical line and I went across this graph, is there anywhere that I run into a problem? Over here at the ends, let's see, let me screen. Put this over here. Over here at the ends, oh, let's move that back. Let's move this forward. Okay, so over here at the ends, I do quit touching the graph, but I've got arrows on the end, right? So that keeps on going. So x values, I could have any x value, all right? I'll give you a hint. If you have a quadratic, its domain is always x equals all real numbers. Or if you're using interval notation, negative infinity to infinity. Okay. All right, range. What do you guys think for the range? What do you think, Leah? 0.125? Okay, so it looks a lot like 0 right here, but Aaliyah did not trust what she saw, right? Which is good. You don't need to trust what you see, especially on these calculators, because this is not the most high-resolution screen you've ever seen. If some of you got those new fancy ones, they're a little better, but they're still not like HD TV 60-inch sort of graph here. So even though it looks like it just hits the x-axis there, Aaliyah went ahead and used the maximum on your calculator. So if we find that, we're actually looking for maximum here. So if we go to the left and to the right, then we get 0.125. So it does actually go just a little bit above the x-axis there. So when I talk about my range, what do I use? Less than, greater than, less than or equal to, greater than or equal to. Okay, I will use less than or equal to 0.125. Make sure you use a y there also because you're talking about your y values. And I'm using less than this time because that's the highest that I can have, so all the y values are below that, so less than 0.125. Now if I use interval notation here, my interval notation here, you always start with your lowest number and then go to your highest number. So I know my highest number I can have, that's 0.125. What's the lowest I could have? What, Jalen? Negative infinity. So I will have negative infinity up to 0.125. Remember, with your infinities, always use a parentheses because it's not included. But we are going to include 0.125 because it could equal 0.125. Okay, questions? All right, let's look at 3. 3 is a little different because 3 is not a quadratic. What is 3? It's a linear equation. We got a line here. So let's think about this one. Remember that you have arrows on either end. So, alright, so in this case, if I think about my x values, does this vertical line touch the graph everywhere? It will, if we consider arrows on either end, right? So that tells me my domain. just like the others, x equals all real numbers, or if I'm doing interval notation, negative infinity to infinity. And range, I'm thinking of y values. On everything we've looked at so far, there was kind of like a stopping point. But on this one, would a horizontal line touch that graph everywhere? Yeah, because it keeps going up forever this way, it keeps going down forever this way. So our range is also y equals all real numbers, or negative infinity to infinity. Okay, questions? All right, we got a couple more here. This one is a cubic, which you really haven't looked at very much. Okay, so you probably haven't seen these before, I don't think. And we won't look at these a lot in this class because we still don't look at cubics much here. But if I look at this, are there any x values where this won't touch? Because you got arrows on the end. What about y values? It's going to touch everywhere because they keep, even though on the graph it ends, it keeps going on forever, right? So in this case, whenever you're looking for domain and range, you're really looking for like a maximum point where there's no higher point than that on the graph anywhere, or a minimum point where there's no higher point than that. So our domain, and as you'll see, what we're looking at right now, what is it pretty much always? All real numbers for your domain, right? Now it can be something different, but for the functions we're looking at right now, it's pretty much all real numbers. Range, in this case, also, oops, it should be a y, all real numbers. Okay, here's our last one. X minus 3, 5 minus x. All right, so for this, my domain is all real numbers, or negative infinity to infinity. Range, we'll have, our range will be something different here. So for our range, we need that maximum point right there. What do you guys get whenever you find that maximum point? It's got a y coordinate of 4, I mean x coordinate of 4. 1 for your y. If you've lost your spider, look down at the bottom, it says x equals, and that tells you where your x value is. Okay. Alright, so for this, Philip, if I've got that maximum point is 4, 1, what is my range? Y is what? So y can be numbers bigger than 1 up here? Less than for this one. So less than or equal to 1. Or if we're doing interval notation. Brianna, what's the interval notation going to look like for y is less than or equal to 1? negative infinity to 1. And what kind of parentheses or bracket do we use for the 1? Bracket. Okay, so these are separate types of answers right here. Like, whenever you see a problem like this, you won't see both of them. So, all of these where we've just got the X and the Y's, these are just our, like, our inequality notation. So that uses the less than or greater than signs. This is a different kind of answer that means the same thing. And it's known as interval notation. So, like, if I gave you a question and said, what is the range of x minus 3 times 5 minus x? You would have probably 4 answer choices there, and I might let my answer choices be like, y is all real numbers, y is greater than or equal to 1, y is less than or equal to 1, y is less than 1, something like that. But I also might use this instead. So if you're using interval notation, you always put your lowest number first, and go up to your highest number. So what we're looking at right now, it's usually one of them is infinity. But we'll see, and what we're going to do in a minute, we'll have a few different things for those. And if it's one where you would have used a less than or equal to sign, use a bracket with that number. If it's one where you would have used just a less than or a greater than sign, which we have not really seen too much yet, then you would use a parenthesis. With infinity, always use a parentheses because you can't actually get there. Okay. Other questions? I do not really care which type of answer you give me, whether you say x is less than or equal to 1 or whether you say negative infinity to 1. Use an interval notation, but you need to understand both of them because I will probably give you some multiple choice questions and it may have one or the other. Okay. All right. Next thing, end behavior. So to describe end behavior, we always say pretty much the same thing. As x approaches negative infinity, f of x approaches something, and as x approaches positive infinity, f of x approaches something. Okay. So if we graph this equation that we have here, x squared minus 2x plus 7. Alright, so we get this graph right here. So, if I'm going to copy this so I can write on it. So, you can kind of think of starting somewhere in the middle of the graph. It doesn't really matter where you're at. So, and actually, well, I don't have time to do that, but, so like as x approaches negative infinity, so as your x coordinates gets more and more and more and more negative, right? So like here might be like 1, 5, and here you might get 0, 6, and here you might have negative 1, 8. Here you might have negative 2, 10, something. I'm not sure if those are exactly right. They're probably not, but that's sort of the pattern that you see, right? So as the x-coordinate gets more and more and more and more negative, what's happening to our y-coordinate? Is it getting bigger or smaller? It's getting bigger. The y-coordinate is getting bigger and bigger and bigger. It's going up, right? We see this side of the graph is going up. So we would say as x, and you can use this little arrow right here to mean approaches. As x approaches negative infinity, f of x approaches. If the number's getting bigger and bigger and bigger and bigger and bigger and going up, 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 what would that be? Positive infinity. So on the, basically, this right here, this just means we're looking at the left side, right? And if the left side, if the arrow goes up, it approaches positive infinity. If it goes down, approaches negative infinity. All right, and then for the other part, we would say as x approaches positive infinity, f of x approaches. So in this case, I'm going to use green dots here. Let's say we start here in the middle. You know, at this point, it might be like 2, 6. And here maybe we have 3, 8. And here maybe we've got 4, 10. Those aren't exactly right, but they're close enough for what's happening. So as our x gets bigger and bigger and bigger, what happens to our y? Bigger and bigger and bigger. So as x approaches positive infinity, f of x approaches positive infinity. And so when we see this right here, as x approaches positive infinity, that just means we're looking at the right side of the graph. So quadratics are pretty easy to do in behavior 4 because quadratics, either both ends go up like a smiley face or both ends go down like a sad face, right? So the first part of what you're going to say is always the same. As x approaches negative infinity, f of x approaches blank, and as x approaches positive infinity, f of x approaches blank. So that part's always the same. Then we just have to decide, I can do this one without even graphing. Because I know if I've got 3x minus 5x squared, what does that parabola look like? It has a negative 5x squared, which tells me it's a sad parabola, right? So as x approaches negative infinity, what happens to our f of x? Negative infinity. It goes down on the left side. And then as x approaches positive infinity, what happens to f of x? It also goes down, right? So we have negative infinity. Now, not for all equations, because lots of them are different, but for a quadratic, those two always have to be the same. They're either both positive or they're both negative there. If it opens up, if it's a smiley face, they're both positive. If it opens down, sad face, they're both negative. Okay, questions? All right, we are going to stop for today because I want you to have a little bit of time to start working on some midterm review stuff. After our midterm, you're going to finish these notes. I'll probably do a video so that you can watch it, and then we'll have some work with this. But we're going to stop.